I'm really privileged to be here, and thanks for giving me such an honor. And so some of the background and information is already known to you. So I'll be talking about the various aspects of satellite communication. I'll start with who we are, about us, then mission statement. I will also talk about our team and representation of global companies, introduction about satellite communications, our products, customer overview, and at the end, I'll be talking about the prospect of new engineers who are just coming out of the college, what they should be looking at and what they can achieve in their career. A lot has been talked about myself, and I'll be just giving you a brief introduction about our company. Optimum Viking Satcom is the one of the fastest growing company in the field of satellite industry. And how we achieve is because of we are highly experienced in the field of satellite towards sales, marketing, technical support, and also we provide a very high quality of customer support and the cost-effective solution. We provide a one-stop platform approach to all our customers, whosoever comes with a requirement. And what is the advantage we have is because of our experience, we give them a very good and optimum solution. That's the name describes of our company is Optima. We deal with the complete range of satellite equipments, starting from the other than baseband equipment. We offer the RF products, we offer the transmission line products, and then we offer the antenna products, which is used for the transportable, static, as well as the earth station equipment. When we started and we were thinking of setting up a company, we started with a mission statement that to be our customers' preferred supplier and partner by offering high quality satellite equipment used for communication and broadcasting products, broadcasting segments. We are an ISO 9001 certified company with a headquarters located in Michigan, US. We are an approved vendor with DRDO, ISRO, and most of the other government as well as big corporates. You can look at the building what we have in the US, Michigan. We participate in international exhibitions and conferences, and this was one of the recent picture of we participated in international events called Convergence India. You all are invited. Every year it happens in Delhi at Pragati Maidan. So you all should go, and it is open for all. So you guys can come over. Next year again we will be participating. Have a look, and you can understand and look at the technologies which are available in the field of satellite. These are some of our partners and teammates. So it's a nice picture. How we achieve by to our customer and provide a best quality of services and products. Because most of the satellite equipments are manufactured out of US or Europe. Very few of the equipments are made in India. And how that is possible? We cannot have all the time US engineers are flying over to India and providing the services and support. What we do is myself go and our team goes there to the US and Europe, learn the technologies, and then we implement those technologies into our Indian customers. These are some of our US teammates. Already you got my background. Mr. Paul Wagler is our president. He was my boss in aerospace company, one of the Fortune 500, who the name is Cobham Satcom. There I was a country manager for India. And they are only the one who makes the air-to-air refueling parts. Wing Commander Dayal is quite familiar with that. So what is that air-to-air refueling parts means? When the fighter aircrafts are fighting the war, you won't get a chance to land at the ground and then refuel them. So what will happen, there will be two aircrafts. So one aircraft will fill the others in the air. That's why it is called air-to-air refueling system. And that is only was available with a company called Cobalt. And every fighter aircraft has that system in the world. So I was heading for their Satcom division in India, and he was my vice president I was reporting to him. But what happens when you work for a very big corporate? There are always plus and minus. You will be given a different task, you will be asked to run, and then your hands on legs will time. So we decided at the end, in 2010, that why don't we let us come out of these bindings and let us fly. And that's how we invented the Viking Satcom and the Indian Airman's Optimum. And by the grace of God, in last 5+ years, we have got a significant platform, significant projects. What we did, we'll talk about that in next slides. Then we have Mr. K.T. Shah is our General Manager, Technical. He spent about 35 years in the ECIL, Electronics Corporation of India Limited, wherein he was involved in developing, designing of larger station antennas, whether it is for communication purpose, broadcasting, or for that matter TT&C application as well. One of the engineer, Mr. Pandey, he started with me about 10 years back at the salary of 5,000 rupees. And from there, I have groomed him, and he is now one of the core member of our technical team. And he has been trained various times in the US and is one of the good and expert in the satellite field. Then we have a lot of engineers and the managers with us. Mr. Tarun, as sir has mentioned, he has recently been added into our team, and he did his MTech from UK, not Uttarakhand, United Kingdom, and now he's with us. He's taking care of the pre-sales, sales, and technical support. I talked about that we offer the complete range of products, and at the same time I also mentioned that these products are not made in India. Most of them are not made in India. So these are made outside India. So we have exclusive partnership and tie-up with them to sell and support those products in India. So one of the companies, ASC Signal, on the right side, you can see it's a larger station antenna, and they are the world leader in the field of earth station equipment. These are the antennas. I don't know how many of you have seen other than the faculty members. Can you raise your hands? Big antennas like this? Where? Anybody can come? Where? Okay, that's good. But if you go to the sector 16A, Film City of Noida, you will see a lot of those antennas. So that is one of the exercise for the students to visit sometimes and go and see. You will see a lot of these antennas over there because they are, the operation is Dish TV is there, News 24. There are many channels they are running. They are uplink station from them. Then we have an Environmental Technology Inc., again from US, and they are one of the pioneer manufacturer of automatic pressurization systems, also called dehydrator systems. I will talk about that, what is the application of this later on. Then Novatronics from Germany, they are into the different RF switch matrix and other products. We also manufacture some of our own products in US. Acorde Technology from Spain, so they are the pioneer into the solid state power amplifiers, test loop translators, the frequency converters and other things. Similarly, Novella Satcom from UK, making the high quality synthesized frequency converters, test loop translators, beacon receivers. AVL Technologies is again a pioneer into the field of mobile satellite terminal. If you go towards the Rajiv Chowk or any of the DSNG vans or OB vans, you will see most of them are having our antennas on top of the vehicle. Now you remember AVL Technology. So in India we represent them and we support that product. Then we have Norset. Again, Norset is from Canada. They supply the LNB systems. FlexiGuide. FlexiGuide is from UK. They offer the high quality, flexible and twistable waveguides components. I am sure how many of you have studied the students, the waveguides? Can you raise your hands? Okay. What is the use of waveguides? Anybody can come forward and yes.
Provide a particular direction for a wave. Provide
Okay.
a particular direction.
Okay, only direction. Okay, that's the difference. What I'll be giving you and what you have studied in the books. Basically, these are the products comes under the transmission line products. When you want to transmit your high power from the amplifiers to the antenna, you need a transmission line media, whether it is a coaxial or it is a waveguide component. Purpose remains the same, but what is the difference between two is, one is the coaxial cable is used for the low power and low frequencies, and the waveguides are used for the high power and higher frequencies. So if you transmit a very high power over the coaxial cable, cable will burn and there will be a lot of reflection losses, and therefore your VSWR will become very poor. These are some of the waveguide picture what we use in real scenario. So on the left side, these are called elliptical waveguides. When the waveguide length is large, suppose if your indoor unit and your amplifier is sitting right here and you have an antenna up there with the distance is about 100 meters. So what you use is a waveguide which will run through the between the amplifier and the antenna, and that is the elliptical waveguide. Then these are some of the microwave components used widely into the field of satellite. Product folio I have already talked about. We supply and provide almost every products used in satellite equipment, the satellite network. Before I go into the next slide, I would like to show you a small video why the satellite communication is useful and required.
television programs, radio signals, and so on. Principle of satellite communication. The process of communication begins at an Earth station. The Earth station is an installation designed to transmit and receive signals from a satellite in orbit around the Earth. Earth stations send information in the form of high-powered, high-frequency signals to satellites that receive and retransmit the signals back to Earth. These retransmitted signals are then received by other Earth stations in the coverage area of the satellite. The area which receives the signal from the satellite is known as the satellite's footprint. The transmission system from the Earth station to the satellite is called the uplink, and the transmission system from the satellite to the Earth station is called the downlink. Here you have the schematic representation of the principle of satellite communication. To avoid confusion, the uplink and downlink frequencies are kept different. Before designing a satellite communication system, we must choose the orbit in which the satellite is to be placed. Orbits are of three types, namely geostationary orbit or geosynchronous orbit, polar circular orbit, and inclined highly elliptic